Yeah, welcome to everyone that's here right now. This is third or fourth of our webinar trials, Cloud Chats by Ivan. This time we go for something a bit more technical, looking at the world's most advanced database, according to Postgres. They need fighting talk, of course, when being compared with MySQL. So we're looking at one of their reasons for the fighting talk, and this is logical replication, a feature that came in version 10. And my colleague, Marcus Koskinen, is also a solutions architect at Ivan. He has all of the knowledge and all of the info. So he will be introducing and explaining the topic. And for communication, questions, etc., we'll have time at the end, but use the chat, either sending to me or to everyone. Either is fine, and we'll make sure they get addressed in the Q&A stage. And if it's something that is relevant to the slide that's showing as well, then we can always interrupt Marcus and not wait until the Q&A. So yeah, without further ado, take it away, Marcus.
All right, thanks, Chris, and thanks all for coming to this webinar. My name is Marcus Koskinen. I'm a solutions architect at Ivan, based at our office in Berlin. First off, here's a quick slide about the different services Ivan offers. We offer many of the favorite open source databases, queues, and other products like Kafka as a service. You can deploy them on all of the biggest cloud providers. Today, we'll focus on Postgres. So on the agenda today is logical replication on Postgres. We'll start off with some background about replication on Postgres in general, then look at logical replication. That will be followed by a quick CLI example. Then we'll address some pitfalls and concerns that you should take into account when using logical replication. Then finally, a few words about PG Migrate, an open source migration toolkit that's in the works at Ivan. So first off, some background about how replication has been done in Postgres. On high level, replication in Postgres can be achieved through three different ways. First, physical replication through streaming replication or wall log shipping. Second, logical replication, or third, trigger-based like Slowney. Physical and logical replication are based on write-ahead logs, as are most online backup solutions and point-in-time recovery. As write-ahead logs are an essential role here, I'll tell you a bit about them. Well logs are binary log files, sometimes also known as redo logs, that are used in most database systems. A well log file consists of many well records. The idea there is that any transaction performed on a database is first written as a well record, and only then written to the table's data files. This way they safeguard against data corruption that could happen, for example, in the event of a power failure. As the well logs can contain all the changes that have happened to the database during their existence, they can be replayed to bring the database to a given state that it has been in during the well file's existence. So point-in-time recovery. The amount of information written to the well files is controlled by the well level setting. It can have one of three values. Minimal, which has the lowest amount of information. It's faster, but doesn't contain enough data for replication or archiving. Replica, which is the default, it contains more and allows for physical replication, archiving, and point-in-time recovery. Then finally, logical, which has the same data as replica, and also the information needed for logical replication. In releases prior to 9.6, this parameter also allowed the values archive and hot standby. These are still accepted, but they are mapped to replica. Before Postgres 10, built-in replication always happened using physical replication. It is based on WAL, essentially block-level changes sent to the replicas. When using physical replication, the replica is a bit-by-bit copy of the master. The whole database and all the changes are always replicated. Physical replication is widely used for high availability as well as read scaling, so read replicas. The earliest form of physical replication is WAL log shipping, introduced in Postgres 8.2 in 2006. It essentially involves transferring the WAL files to the replica with archive command, which can be any script or command, for example, cp rsync, s3cmd. Postgres itself doesn't mind. In this case, first the WAL file is filled with enough WAL records to reach the segment size, which is by default 16 megabytes, and then they are sent over to the replica. This also means that if there aren't a lot of changes to the database, it can take some time for enough records to accumulate to fill the WAL file. If that happens, there can be a sizable delay in the changes getting to the replica. Synchronous replication is not possible with WAL shipping. The next evolution of physical replication was streaming replication. Introduced in Postgres 9.0 in September of 2010. It is also based on WAL, but sends WAL records instead of the full WAL log files, allowing the replica to stay much more up to date versus WAL shipping. It also allows for synchronous replication, which was introduced in Postgres 9.1. In streaming replication, the WAL records are sent directly over the network from the master to the replica. It can also be used alongside log shipping. As a quick recap about physical replication, it can be used for high availability and read scaling. The replica is always a bit-by-bit copy of the master. Everything is replicated. The replica is always read-only. The replica has to have the same Postgres version as the master, and the replica has to be on the same type of platform as the master. So then, let's have a look at logical replication and how it differs from physical replication. Logical replication was introduced in Postgres 10 in October of 2017. It's a method of replication for data objects and their changes based on a replication identity, typically a primary key. It's used with the publish-subscribe model. Subscribers subscribe to one or more publications on a published node, and the subscribers can republish the data to further subscribers. What this means in practice is that in logical replication, we process the WAL records and decode them to logical changes. So instead of having a record of what bytes change in a data file, block-level changes, like in physical replication, with logical replication, we actually know what rows change in what tables. These changes are then applied to the replica as logical insert, update, delete, and truncate operations in transactional order. This means we can filter what sort of changes we want to replicate and to which tables. To send over the changes that we are replicating, we use the pub/sub model. We first define a publication on the master. That publication is applied to one or more tables, and it can filter based on change types. Then a subscription is defined on the replica and attached to the publication. When a subscription is created, it copies a snapshot of the published tables Then any changes on the publisher are sent to the subscriber in real time. In order to be able to use logical replication, the replicated table needs to have a replication identity. Usually the replication identity is the primary key, but can be any unique index. Ultimately, it can also be set to full, which will make the whole row the key. Another difference with logical replication versus physical replication is that the replica is writable. This allows for some interesting use cases, but does not imply multi-master. Another point of interest is that the destination table schema can differ from the source. The destination table can have more columns than the source. The order of the columns doesn't matter, but the changes do need to be able to go through. So these differences open up some new possibilities. Let's have a look at some use cases that can be achieved with logical replication. First off, you can replicate a subset of a database, for example, just one or two tables. This will be more economic and performant than replicating all changes. Then, as the replica is writable and the destination's table schema can differ from the sources, you can add additional indexes and views. You can even have additional columns. A more advanced variant of this is database consolidation. You can choose to replicate select tables from several clusters to a single database. This is a great use case, for example, for analytics purposes. The replica's security definitions can also be different from the source. You can allow wider access on the consolidated database. Another use case is online migration. In this case, you start replication through the publisher and subscriber, wait for the replica to catch up, then point your clients at the destination database. There's no master promotion involved. You can even use it to migrate to a newer version of Postgres. That brings us to our final use case, replicating between different types of clusters. You can use logical replication to replicate between different versions of Postgres, as long as the destination supports the same features used by the master. You can also replicate between different platforms, like from Windows to Linux, and even Intel to ARM. Now, for a simple command line example of how to use logical replication with one table. First, make sure that the wall level is set to logical on both the master and the destination databases. You can do that with alter system set wall level logical. You'll need to restart the clusters for the changes to take effect. Then we create a source database, and into that a table called test table. We'll then add a couple of test values into that. So a normal create table and a couple of inserts. Now on the source cluster, we create a publication for our newly created test table. You can do that with the create publication. For table specifies which tables will be affected. That could also be all tables to make it apply to all of the tables in the database. In this example, we don't define any publication parameters, so it will go with the defaults, using all of the supported DML operations: insert, update, delete, and truncate. The next step is to create the empty destination table. For a bigger set of tables, we could likely use pgdump schema only, but in this test case, it's simpler to just create the table by hand. The final step is to create a subscription on the destination cluster with create subscription, pointing it at the master's hostname, port, database name, and publication. So that's all there is to it. Logical replication is now running. You'll notice changes from the master are being replicated to the destination cluster. For checking the status of the replication, you can check PG replication slots and PG subscription views. And finally, if you don't need to keep the replication running, like after a migration, you should clean up with drop subscription on the replica, and it will also release the replication slot on the master. It is important to remember to use to drop unused replication slots, as the inactive ones can tie up resources, while records can gather up and fill up your disk. If you want to use logical replication towards an IBM PostgreSQL server, there's a help article available in our knowledge base. It has more examples and also explains how to use the IBM Extras extension to get access to the administrator level operations involved. Now, let's look at some trickier cases that are good to keep in mind when doing logical replication. Logical replication doesn't support data definition language changes, so changes to the schema. Also, for creating the destination tables, you will typically copy the schema first, then start replication. If you need to do changes to the schema while replicating, a workaround is to pause replication, then first migrate the destination, then migrate the source. Note that if you add tables to the publication, you need to update the publication with alter publication. You need to also refresh the subscription with altered subscription, refresh publication to fetch the missing table information from the publisher. Another thing that can cause problems are sequences. The values of sequences are replicated in the table data, but the start values are not. This is not a problem when there are no writes to the replica, but if there are, you need to make sure the auto increments don't collide with existing values. One option for this is to use non-overlapping ranges for auto increments. Then, as we mentioned earlier, logical replication needs replication identity, which is typically the primary key. If there is no primary key, you still have options. Use another unique index of the table, use the full row as the replication identity, or of course, add the primary key to the table. PG Dash has a great article about the issues I mentioned earlier. It's definitely worth checking out. The link is also in the final slide. There's still a couple of more considerations. Large objects, also known as blobs, are not supported. You can work around that by referencing objects on network or object storage. For smaller data, you can store it in the tables themselves. At the moment, partition tables are not fully supported. You can, however, already replicate the child tables explicitly. And there's also good news regarding this. Support for partition tables in logical replication is coming soon in Postgres 13. Another thing to take into consideration is extensions. Version mismatches in extensions, and of course missing extensions on the destination can cause problems. Some extensions like Timescale DB do not currently support logical replication. Finally, especially with managed services, it's good to know that some operations related to logical replication require superuser privileges on the database. Ivan addresses this through the open source Ivan Extras extension, which exposes those operations. AWS RDS has a custom RDS replication role which enables this. Others like GCP Cloud SQL and Heroku Postgres don't support logical replication at all. Now, before ending the presentation, a few words about INVDB Migrate, an open source migration toolkit in the works. It is an Ivan-built open source tool written in Python. It is currently in development, and the first release will target PostgreSQL. There are plans to expand to cover also other databases, for example, MySQL. It is not restricted to Ivan products and can also be used for migrations between non-Ivan DBs if you want. The tool supports logical replication. It does sanity checking on the source and target, such as version compatibility, extensions, and permissions. It also supports PG dump as a fallback, and there is support for the Ivan Extras extension for admin level operations out of the box, enabling easy migrations to Ivan. Initially, the tool will be integrated to the Ivan platform for migrations. It is still under active development. More switches and functionality are being added. It will also be open sourced as a standalone tool. A blog post will follow when the tool is publicly available. Here's an example of what its usage looks like. On a general level, you define a source and a target by their connection strings, and it will get to work. So finally, the last slide and final words. Logical replication allows for a lot of use cases and many different setups. It is definitely something to look at if you're looking for the partial replication of a database, want to consolidate multiple sources to one target, want to replicate between different PostgreSQL versions or platforms, or want to do online upgrades or migrations. It does also have a lot of moving parts, so always plan and test your migrations as well as possible. That was it. Thank you very much for your time. I'll give it back to Chris.
Cool. Thank you. And yeah, massive thanks to Mr. Max Koskinen for prepping the content. The slides have been added to our presentations repository. You can find on github.com/Ivan. Webinar Jam is supposed to show a message that says slides here, but apparently that's only visible to me, which is cool. But I have posted that into the chat. And since we have some time and there have been some questions, we'll go straight to those. First from David, it says, if we want to replicate an entire database, can we create a publication for a database rather than a table?
You need to create the publication with the all tables switch, so that will essentially do it. So and that's in using PostgreSQL terms, it will then apply only to that database and not the cluster. But all tables will take care of that.
Cool, thanks. So using tables makes it possible. Another question that's come in is someone is currently using Postgres on Azure. Could they use logical replication to migrate to somewhere like Ivan?
I haven't tried logical replication on Azure, but I did notice that they have now logical replication in public preview, at least for the single instance servers. So they do support logical replication, at least on some level. So it should probably work there.
Nice, thanks. If anyone does have any questions, still feel free to add them to the chat. There's only about 2 more to go through, so add them in. If you have anything, we'll move on to the next one. You mentioned that logical replication works for different versions of Postgres. Does that mean it could be used with versions of Postgres before version 10?
Not really. You have to have Postgres 10 as the source, and then you can replicate to a newer one or of the similar version.
Yep, that makes sense.
Internally, there is some functionality. And actually, to expand on that a bit, there is the PG Logical extension by the second quadrant that does allow for that, but you have to have it installed on both sides. But the shorter answer is no.
Yep, reasonable. That seems like the TLDR of it. So yeah, finally, is there a way to know if my subscribers are in sync with the publisher?
Yes. So you can check the PG replication slots view and the PG stats replication. I think it was the last slide in the CLI section has a long SQL command that should be pretty good for checking the lag between the replication. So it's comparing the WAL files consumed and sent. Nice.
Okay, so we already have references for it as well. And then another question has come in saying for highly available setups, should they use physical replication rather than logical because they suppose it's more reliable?
It depends a bit on the environment, but if you know that your both instances are very similar, and then you're good with physical streaming replication. It'll work fine. If you have the same versions and same servers, then you'll be good. Logical replication is great when you want to replicate a subset or then replicate to a target that can be a bit different. And also for migration use, so you don't have to mess with promotions and so on. So a streaming replication is still great and a good tool. So for a high availability cluster, that's a good choice as well.
Okay, I think that's pretty much everything. So yeah, thanks for the questions. Again, massive thanks to Marcus. It's worth checking out the Ivan organization on GitHub anyway, because the tool that Marcus mentioned will be open source there, as well as a bunch of other open source projects that we maintain or contribute to. So yeah, you can almost leave now. Our final webinar before we take a summer hiatus will be Apache Kafka 101, the why, the what, and the how, and that will be on June the 17th. So keep an eye out for an invitation to this, and feel free to send any emails or requests to webinars@ivan.io. Thanks, everyone. Thanks, Marcus.
Thank you very much. Thank you, Chris.
Bye.
Bye.